Hello, this is Mr. Waterman, and we are now working in section 3.4, finding and using slopes of lines. We're going to use those to determine whether lines are parallel or perpendicular. Bunch of definitions to start with. So first of all, slope, which you should be familiar with from Algebra 1. So it's defined as rise over run. We're going to use that definition quite a bit today. Also, increasingly as you move on in math, you'll hear it as described as the change in y over the change in the x direction, change in the y direction over the change in the x direction. And we have a formula to calculate that. So if you're given coordinates, you can take the difference in the y coordinates and then divide that by the difference in the x coordinates. All right, today we're going to be using rise and run an awful lot. Basic concepts about slope. We have 4 different concepts we'd like you to know. So first of all, negative slope. As we're going from left to right, same direction as you read, if a line is going up as you go left to right, we call that a positive slope. Conversely, if a line is going down as we go left to right, like line J here, then we say that that line has negative slope. And then we have 2 special cases. We have one that we call zero slope. Okay? We don't say no slope, we say zero slope. And that is a line that is perfectly horizontal.
Right? Kind of like a bunny slope skiing.
And lastly, the hardest one conceptually for most of us is what we call undefined slope.
Which means you can't ski it, it's a cliff.
So, it's a vertical line, just like line N here. So let's go ahead and look at an example using these. Be sure and copy these into your notes, these 4 concepts and the definition of slope with the formula. So our first example here. Bring over our definition. Here we go. So what we want to do is find the slope of line B and then of line C. So line B, I'm going to use the rise over run definition. So since this is already graphed, what I'm going to do is draw what I call a slope triangle. All right. So first of all, we're going to see how far it goes in the up and down direction, what we call rise. So I'm just going to count it off, going from these 2 defined points on line B. So 1, 2, 3, 4, 5, 6 is our slope. So we've gone up 6, so I write that as a plus 6. All right. So slope of line B is going to be the rise, and we have positive 6, and that's going to be divided by the change in the x direction, or the run. So I'm going to count off the run, 1, 2, 3, and that'll be my denominator. So simplifying that, we get a slope of 2 for line B. All right. Next line, we're going to find the slope of line C. So I have these 2 points that I'm putting purple dots on. All right. So first I have to find the rise. There isn't any. So slope of line C, the rise is 0. And then we need to find the run. So going from this point to this point, we're just going to count it off. 1, 2, 3, 4, 5. So the run is plus 5. All right, so we put the run underneath as a denominator. And then when I simplify this, 0 over 5 simplifies to 0. So this, line C, has a slope of 0. Okay, please watch part B video. This concludes part A.